Hello, in the last few videos we were talking about the dot product and the scalar product, but I never provided a proof. So that's what we're going to do. We're going to prove that the u dot v of any vector is equal to the absolute value, the magnitude of u times the magnitude of u times the cosine of theta. So here we go. So if we given two vectors in space, we'll call this vector u, and this one here, this would be vector v, right? And then if I make the vector right here, make that a little bit better, make this vector right here, this would be the vector u minus b, right? So vector u minus b, right? Good. And then this would be the angle between it, theta. Good. So, and we can use the law of cosines to prove this guy right up here. So, using the law of cosines, we'd have, if this is the angle we have, then it would be the magnitude of the length of this guy, which would be the magnitude of u minus b. Good. And that would be equal to magnitude u squared plus magnitude b squared minus 2 magnitude u magnitude b times the cosine of theta. And we're going to start over, well, this should be, this should be squared, right? So we need this length squared is equal to this length squared, this length plus this length squared, minus the 2 times the lengths of these two times the cosine theta. Good. Now we're going to recall from the previous video, we had a property that said that if we had vector a times vector a, we showed that that is the magnitude of a squared. So I'm going to use this rule right here for this guy right here. Since this is magnitude squared, we can take what's in the vectors inside of it, u minus, a little messy there, vector u minus v, and we can say times, or dot product, u minus v. Good. And we also showed that we have a rule that we can do distributive property with these. So this guy, so we can do distributive property, vector u times vector u times vector u, should be a vector u, and then we'll have u times a negative v, and then a negative v times u, they're the same, so there's going to be a middle term, which is going to be 2 times u times v, and then the last term is going to be plus, but it's going to be vector v times vector b, right? So moving on the left hand side, I'm just returning this, and we can use this property again, right? 2 vectors times itself is the magnitude of that vector squared, right? So this is going to be the magnitude u squared. I'm going to have minus 2 u dot v plus magnitude of vector v squared. And what's that going to be equal to? This is the left hand side. I've changed it. The right hand side is going to be vector u squared plus vector v, magnitude of vector v squared, minus 2 magnitude u, magnitude v, running out of space here, cosine theta. And then look what happens, right? The magnitude u is going to cancel out here and here. Magnitude v squared cancels out. And then what am I left with? I can cross out the negative 2's. And then finally I get u dot v, the dot product, is equal to what we have left over here, which is magnitude u, magnitude v, times the cosine of the angle theta between them. And there you go. We have shown, we have proven the dot product. And mind you, this is what we call the geometric, this is the geometric dot product. And we're going to learn in the next video, there's another formula for the dot product, and that's the algebraic formula for the dot product. Sound good, guys? Thanks.